Hi, everyone. You should see a terminal window here and my face, ideally, and hear me. Okay, all good. Great. My name is Rusty Russell. I work for Blockstream. I am the lead of the C Lightning team, which was the first Lightning implementation to exist. It's been through a number of iterations since then. I also am heavily involved in the Lightning spec process, making sure that we all interoperate and everything else. Today I'm basically going to run through setting up C Lightning and kind of playing around with a few nodes, and then I'm going to talk about a couple of exciting things, things that I really like. C Lightning is designed to have plugins which are increasingly powerful that can do all kinds of things. So I'll demonstrate some plugins, show you where to find more and those kind of things. And then at the end, I'll talk a little bit about what I'm working on at the moment. In the latest release, we have experimental support for a draft part of the spec called offers, and I'll show you some of the cool things that we can do with those. So we will stop for questions at various points, and feel free to ask and interject with questions if you want, and I will try to cover them. So here in the window, you can see I've actually got this is a fresh Ubuntu box somewhere in New York, the DigitalOcean data center in New York. And I'm pretty much going to start with, download and install C Lightning. You should not be running as root, but of course I am, because I'm going to throw this box away anyway. We're going to run the latest master, because why not? There's a doc called install, which describes what you should, how to build it on various platforms. And in our case, we basically want these lines here. And then we want these lines here. So I will do that. I already did this because that actually takes a while to install those packages. So that's the one thing that I did prep on this machine beforehand. I will snap install Bitcoin Core. You don't actually need Bitcoin Core. There are some plugins that will allow you, for testing purposes, to instead of asking Bitcoin for stuff about the Bitcoin network, you can install plugins like Sauron is my favorite. It backends all the requests onto the Blockstream Explorer, which means you get no privacy whatsoever. But it's great for testing. But it's not that hard to install Bitcoin Core. So we set that up. Use a local bin. So now we configure. I'll enable the developer options because depending on what you're doing, they can be useful. And make install. Cool. Now we will probably run into an issue here where I do a massive parallel build and it does that. Okay. So as I was testing this, I ran across this bug that I have not yet fixed, where if you do a parallel build from a very clean tree, it sometimes tries to build it before it has actually checked out the submodules, and it gets this error. Second time, works fine. So ignore the man behind the curtain there. I will file a bug report for that. Okay, so we're building and installing. Pretty straightforward. I could just install one of the packages. There are Ubuntu packages. There are various different precompiled signed binaries, but in this case, I thought we'll do it from scratch. Why not? It is pretty quick to build the whole thing. Now, in the contrib directory, there is an interesting script that we're going to use that makes it really easy to set up multiple nodes on what's called reg test. It's basically a local Bitcoin chain that lets you just play around locally with coins and things like that. So we are going to use that. That script, which Lisa wrote a while ago, just makes it pretty easy to set things up. So here we do. There we go. It is all installed. So start reg test. You source that. Oh, and it wants. It's upset because we've never run Bitcoin before, and so it's going. I can't find your Bitcoin path. That will keep it happy. Okay. Right, now that creates an alias called startln, which just, you can give it, tell it to fire up 3 nodes. There you go. We've just created 3 nodes, and it's created these commands for us for convenience: L1 CLI, L1 log to look at the logs, etc., and BT CLI to talk to the Bitcoin D, and stopln to shut everything down. Okay. Cool. So in this case, we actually need to CLI create wallet default. You have to create wallets in modern Bitcoin D, and I'm running the latest Bitcoin D here. So let's mine some blocks. Generate 2 address. We'll mine 100 blocks. Bitcoin doesn't work for the first 100 blocks because you can't spend the coins that you've generated. So there are no coins in the system. So we're going to need some coins. So we just basically get new address. We'll generate 100 blocks. On a rake test, that's trivial. So there we go. We just mined 100 blocks. Fantastic. So Bitcoin is all set up. Okay. Now we started up our 3 nodes on rake test. They're not connected to each other. They're all isolated. And their homes are in L1 rake test, L2 rake test, L3 rake test in temp. So let's look at the PID file here. So if we do a PS tree -a -p on that one, here you can see Lightning D, and it's created a whole heap of little sub-processes. 3 of these, the Lightning Connect D, the Lightning Gossip D, and the Lightning HSM D, are subdaemons of the main Lightning process, and they do various parts. Connect D, like you expect, creates connections and receives connections. Gossip D handles all the gossiping around the network, and HSM D looks after our secrets. There's also these other things here, like AutoClean, BCLI, and these are all these plugins that I talked about. By default, C Lightning comes with a sort of a minimal set of plugins that do various operations. And over time, we've basically farmed stuff out from the core Lightning D into these separate plugins. So fetch invoice is a plugin. The pay command, which people use all the time, is in fact a plugin that talks to like low-level APIs. And it handles all the stuff like retrying things if payments don't go through and all that stuff for you. So increasingly, plugins are where the action is in the C Lightning world. Okay, so now are there any questions so far? So we've fired up 3 nodes. We've looked at one of them. We haven't done anything with it. It's sitting there. Oh, what is fetch invoice? I'm glad somebody asked that. I will cover that at the end. It's to do with the experimental offer support. We have fetch invoice, and I will demonstrate that, I promise, Michael. Okay, so let's talk to our L1 CLI and do a get info. Okay, this basically tells us about our node. Now, it's given it an alias here. The aliases are made up NSA code names. And because we built the developer version, if you recall, it appends the name, the actual version. That doesn't normally happen unless you're developer version, but that lets you tell, since you're in dev mode, exactly what revision I'm running on this. This is 104 revisions since V093. You also get a favorite color, which is always nice. And there's a few different, we have no active channels, we have no peers, etc. Now, in this case, and one important thing about Lightning is that we have this idea of an address versus a binding. So address is what you tell the world where to talk to you. And binding is where you actually bind. In this case, we haven't told the world anything because we're basically a private node. But we've bound to an IPv4 port on loopback, port 7171. So let's pimp our node a little bit. If we look in, temp L1 reg test, our config, the scripts generate a default config for you, which turns a few options on, which is pretty straightforward. So let me, now this is the one option that everyone should enable, gated APIs equals false. You can turn off all the APIs we've deprecated. Over time, we change APIs, we deprecate old ones. If you add this to your config, you will disable them, so you can't use them by accident. So that's really good if you're developing a plugin or something. You want to make sure that it's not going to break in 6 months' time. You should always run with those disabled. So let's then stop it and restart. Lightning D, official Lightning L1 reg test. There we go. Restart it. Oh, let's remove the typo. Cool. There we go. And now we should be able to L1 CLI, get info again. There we are. Okay. Now, probably the most important thing of info is actually this ID. This is your public key. This describes your node. It's derived from the secret that your node generated when it first started up. And that's the thing by which everyone will see you. Okay. And Michael says he knows some strangeness between IPv4 and IPv6 bindings. If you read Lightning D config, there's a whole manual page that describes all the possible options in here, and it has a whole section on the issue of addresses. So if we go down to here, networking options, right? In particular, you can specify an address, and you can specify, which says, okay, this is the address I want to use, and that applies both, hey, this is the public address, and it's also the one that I want to bind on. Figure it out. But there's also, you can explicitly say, no, bind to these addresses and announce these addresses. So you can also separate it into two parts, binding and announcing. So you get very fine-grained control depending on what you're doing. But addra is the one you normally use. Oh, look, this is my address. That's fine. And it has all Tor options and everything else. It's pretty nice. So the question of IPv6. So it should just work. By default, if we can find IPv6, we will bind to it and we will advertise it. But I haven't retested IPv6 explicitly recently. So Michael, I will get back to you on that. This box is IPv6 enabled, but of course, these are not real nodes. I have IPv6 enabled on my other ones. Auto listen equals true. That is also the default. So you should bind address equals. Yes, so if you specify bind address equals and auto listen, you should get an IPv6 bind address, and it should. Okay, interesting, because that should have worked by default, Michael. But I will. Okay. I wonder why it thought the IPv6 address was not valid. Okay, I will look into that. Thank you. Cool. Okay. Now we actually started 3 peers. But I did want to point out this thing. If you're doing scripting and stuff, sometimes the JSON can be annoying. We have a flattened version, -f, which basically just spells it out 1 per line and breaks it down that way. If you have multiple entries, it puts like a bracket there. So if you're using shell like I do or grepping, -F is your friend for the command line. Okay, so let's connect L2 CLI, connect to this guy here. At 127.0.0.1 :7171. Okay. Cool. So L2 connected to L1, it got the ID expected, and it has these features. You need to read the spec to figure out what those features mean, but they're all there, and it's compatible. Otherwise, it would have refused to connect. So if we do L1 CLI list peers, you can see L1 says, hey, I've got this peer, it's connected. It has no channels, though. Okay. Now, at this point, the common question is, I've started up my node. Why doesn't it appear in any explorers? Well, other than the fact we're on reg test, and so there's no explorers here. But let's connect our explorer node, L3, here. We'll connect it as well. Okay. And we'll do L3 CLI list nodes. And it gets nothing. Okay, list channels, nothing. Okay. And the reason is that you cannot advertise yourself as a node until you have a channel, a public channel. So, okay, obvious thing, let's make a channel. Well, we're gonna need some funds, so we'll get a new address. There's our Vec32 address, PTCLI send to address get Bitcoin to send us. Oh, let's be generous. Send us all a whole test Bitcoin. Oh, I don't have enough. Okay, I need to generate another block. Okay, there we go. Okay, and then I need to mine it. So let's mine a block there. Cool. L1 CLI list funds. Oh. Should show us. Hey, look, we've got a funds. We've got like well, a lot of MSATs there. Okay, cool. So let's fund channel. L1 CLI fund channel. We need to tell it what peer, and the peer is 2. We did it here. This one. Fund channel to this one, and let's use amount equals. So let's do 100,000 sats. Okay. Now, reg test, of course, doesn't have fee estimation, and it's like I have no idea what fee to use. So you can actually CLI help fund channel, fires up the man page, and you can see we have ID and amount, and we have an optional fee rate. So at this point, we can go ID equals. So there's 2 ways to specify things. You can specify things with -k, which basically is keyword pairs, or you can just specify them as a line. And if you can't remember what order things are, I prefer using -k. So amount equals, and then we do fee rate equals 253, like that. Okay, cool. It has done the channel negotiation. It's got a transaction that opens our channel, and we've done everything. Okay. Right. Michael says he had troubles in rig test node connecting to Bitcoin D. Strange. For here, it just worked. If it's running on standard ports for rig test, it will connect straightforwardly because it actually calls out to Bitcoin CLI. And so as long as Bitcoin CLI works, it should work. If you need to add options if you have put a password on it, which you should probably do in real life. So you will need to set those. Okay. Now, of course, again, we need to mine a block because nothing happens in Bitcoin until blocks get mined. And so cool. Now we go, great. We have a channel. Well, good. Let's ask our explorer, L3, list nodes. Tell me about the nodes. You should see both of them. Oh, nodes. Okay. And it doesn't. And the reason is that channels cannot be made public until you've got 6 blocks. And they're still 6 blocks deep. So let's mine another 5. So once you've got 6 confirms, we consider it worth telling the world about. Then it's got to catch up. So let's give it a little bit of time. Oh, there we go. So this is the gossip network. L3 is connected to L1, but it can also see L2, this L2 here, because the nodes continually talk to each other and say, hey, cool, there's this node. And indeed, there's these channels. There we go. When you do a list channels, you get it in 2 parts. We consider it like 2 halves of a channel. So this is actually one channel in one direction and then the other direction, right? It tells you the fee rate and everything else, the maximum amount, minimum amount, source and destination, which is obviously reversed for this one, the short channel ID. It's public. You can tell us there. Okay, cool. So at this point, once you've got your channels to some existing node and you've got 6 blocks behind you, at that point, you will start peering explorers. Okay. Are there any questions about that stuff so far? Because I want to move on to plugins. So. Will there be a plugin to use the LN Sync API? You could. I don't plan on writing a plugin to use the LN Sync API, but it's certainly something that somebody could do. I mean, our plugin infrastructure is pretty powerful at this point, and you can do just about anything, including mess your node up pretty badly. So that would be definitely a fun project for somebody to take on. Okay. Short channel ID used. Okay, so short channel ID here. A short channel ID is literally the location of the funding transaction in the blockchain. In this case, it's in block number 103 because we're reg test, right? We've only got 103 blocks. It is transaction number 1, and it is output number 1. So transaction number 0 would be the Coinbase transaction, and number 1 is the only transaction in the block. And it has 2 outputs. It has a change output and a main output. The change output is obviously output 0 in this case, so output 1 has been used. So that's actually how you read a short channel ID. And we use those all over the place as a shorthand because we have a common blockchain, right, to refer to channels by their funding transaction. Okay, so cool. Now, let's talk a little bit about plugins. So I'm going to go back here, git clone. There are plugins all over the place, but we have kind of a semi-curated repository of them. Lightning D plugins here. LS plugins, and you've got a few here. So we go into plugins. But let's now. Most of them are written in Python, but not all. We're seeing some in Rust. One of my favorite plugins is called Help Me. So we'll do that. Okay, obviously I failed to install that. Let's do that. Okay. Okay, so we will install the dependencies, the Python dependencies for the pip plugin. Sorry, the Help Me plugin, like this. Cool. Right. And then we can actually start the plugin. It used to be that to start a plugin, you had to put it in your config file and spell it out, but there's runtime support now, so you can just go plugin start, /plugins helpme.py. Cool. And that's listed all the plugins, and we can see that help me is true. This adds a command called help me. Okay, so we do help me. Right. Okay. Right. Node maintenance and sanity checking. Okay, I will get to that, Michael, after I've covered this. So interestingly, Help Me's job is basically just to help you. Like, what do I do with my node? I've got it set up. Okay. Now it's happy we've got some funds. Yes. And we've got 2 peers, in fact. And we even have a channel, right? But it's like we've never made a payment. So you can go, okay, help me pay, right? And it goes, you can use the pay command to pay an invoice. It doesn't actually tell us how to get an invoice. But in this case, what we'll do is we'll get an invoice, right? We will L2 CLI help invoice. Tells us how to do an invoice. You have to give a amount, a label, and a description, an optional, a whole heap of other things. So L2 CLI invoice. Amount can be literally any, which means that the payer decides. In this case, let's do 100,000 sats. So all the things that take amounts allow you to, I strongly advocate you putting a suffix on them. There's BTC, and of course you can have point BTC. You can have sats, and you can have MSats everywhere, depending on what you want to think in. So in this case, sats. And we added those appendices, we made those suffixes universal after, I screwed up once and did MSats when I meant sats and was out by a factor of 1,000 and things got nasty. So you've got to give it a label and give me money. Okay, cool. Right. Now here we get the Bolt 11 invoice that comes out. We also get some other information. It gives a warning. It's warning that the peer is a dead end, right? So all the peers that we seem to be an island, right? All the peers we're connected to don't seem to be connected to anyone else. In this case, we don't care, but in general, that implies that we're not well connected. It also believes this warning MPP capacity, which is actually a side effect of the fact that once it eliminates all the dead ends, it's like there's not sufficient capacity for anyone to actually pay this invoice. That's okay because we're paying from one of the dead ends. So let's do that. L1 CLI. L1, please pay that invoice. Boom. Nope, pay that invoice. Thank you. Cool. Oh, let's cut out the extra token. There we go. Cool. L1 at this point is talk to L2. Oh, wow. That is strange. Okay. That obviously should have happened instantly. Well, L1 CLI, pay status. What are you doing? Okay. Oh, it's getting upset with me. Okay. It split it into 5 subpayments. It then failed to find a route through for several of them after it eliminated. It got a temporary channel failure because it could not fit them all in the channel. Okay. What did I do? Oh, okay. Right. It literally can't get that much through. I did not mean to do 1,000 sats. I meant to do 1,000 M sats. Oh, test pay 2. Okay. Here we go. Now we'll pay this. L1 CLI pay that one. That's what I meant to do. Okay. Ran out of routes. Can't attempt payment. We have no channel to add an HTLC. Oh, wow. Okay. This is a fun experiment then. What do you think we're doing? L1 CLI list peers. Okay. We're not connected anymore. Okay. So somebody got upset with us and hung up on us. L2 CLI log. L2 log. This was not part of the demo. Hold on. I'll see what happened with L2. L2 seems reasonably happy. Update fee. Oh, okay. It's gotten upset with fees. Okay, right. Let me mine a block. Generate to address. We'll mine some blocks. That will have closed the channel. And let's do a fund channel. Okay. Oh, well, let's do a connect again. Oh, not that one. That one. Let's open a new channel. Okay. Yes. So I keep thinking that we should that we should probably hack up something so in rake test it doesn't actually ask it for fees and get upset. Okay, we are still upset with not being connected to that one. Okay, why is that true? Yeah, we're going to fail here. Okay, they're getting upset with each other because they're fighting over the previous channel. I knew this would happen. Okay, so I will do stop ln, which will shut everything down and kill the log. Okay, and then I'll do a start ln. This is why we play on rake test, so we can do all these things. Okay, cool. I will connect L2 to L1. Right, I will fund channel there. Okay, I will really start again. L star. Okay, this will now regenerate everything when I do a start ln. No, stop ln. Stop ln first, Rusty. Okay, things died because I deleted everything underneath them. Okay, there we go. That is expected. Oh no, now you're all upset with me, aren't you? Okay. Kill all lightning D. You all dead? Okay, good. Now stop. Okay, now start. Right. L1 CLI get info. Sorry about this. I will L2 CLI. L1 CLI new address. Okay, BT CLI. Let's get some funds in there. BT CLI. Send to address. That one. One. Okay. Oh. Create wallet default. Create wallet default 2. Okay. All right. Now send to address. Damn you. 105. Come on. Okay. So Bitcoin D's default wallet stuff is changed and it's interesting. Okay. There we go. Now we can send some funds. Then we can fill to L1 CLI list peers. Okay. L2 L1 CLI get info. L2 CLI connect to this one. Of course, it's a new ID because it's generated the whole thing from scratch again. 127.0.0.1:7171. Okay. List peers. L1 CLI fund channel to this one. And let's do 100,000 sats. Okay, and we'll need a fee rate, 253. Oh, we need to mine a block. Generate to address 1. Okay. Normally, we have blocks generated in the background, but in our case, we're running everything manually, so we got to do it. There we go. Generate another 6 blocks, another 5. There we go. Okay. So we finally have everything hopefully back to normal. Now, our plugins. L1 CLI plugin start /plugins help me.py. Okay, L1 CLI now has a help me command. Help me. There we go. Cool. No, we've never done it. Now let's do this. L2 CLI invoice. Let's do 10,000 sats. Test pay. Give me money. Okay, we create an invoice. We pay it. Using this. Cool. There we go. Payment went through. It's complete. All good. Now, if we is help me happy? It's cool. You've made a payment, but you've never received a payment. Okay. Right. So now we can help me invoice, and it will tell you, hey, you should create an invoice, and here's how you do it. So we'll create an invoice. We will do wait, invoice. Let's ask for 1 sat. Test pay. Say, give me money back. Okay. Cool. And then L2 can pay that invoice. If we ask for help me, it will say, help me. It will tell us, hey, you've kind of incomplete. No payments have succeeded yet here. Okay. Right. So L2 pay the invoice here. Okay, there we go. And now help me is a lot happier. Cool. So it actually gets this number wrong. It says it's 0 payments received. I have put that on my bug list. So finally, stage 6, add some bling. And so what you do is you go help me bling. And he goes, okay. It suggests you basically edit your config. It's suggested in your home directory, which it normally would be. See, currently we're called weird genesis - whatever, and our favorite color is light blue. So it suggested that we could put this in here, and give our node a name. So let's do that. Temp L1 config. Okay. Down the bottom, we will paste that in. Q. Okay. L1 CLI stop. We'll restart. And cool. And now if we L1 CLI get info with a G, there we go. Our alias is flowers by Irene. Our color is is now a lightish red. Actually, it's actually reasonably bright red. Okay. Now if we connect L3, it should see the updated name. So L3 CLI list nodes. There we go. Cool. And here it's got flowers by Irene in a new color. So that will show up in Explorers after some small delay. Cool. Okay, so yeah, I thought about doing this on regtest rather than doing it on, on testnet rather than regtest, but which is good. You don't have to control Bitcoin all the time, make blocks and stuff. But on the other hand, you can sit there for a while nothing's happening on testnet. Signet's actually pretty good if you want a more reliable experience. But in this case, I wanted to show exactly what was happening. Okay, so we blinged our nodes. Help me should now be help me. Oh, there we go. Oh, let's see. Help me. Really? Oh, because I did not put the plugin in. I literally added it dynamically. So plugin start. Okay, unless you put them in the config file, it's basically a transient thing. Cool. There you go. So add a plugin. You have not added plugins. Try help me plugins. In this case, we can add a plugin. Okay. To make a plugin permanent, you put it in here. Let's add plugin equals home. Actually, it's root plugins. Help me.py, and let's add another one. Root plugin equals root / plugin / summary. Now this shows you .py. So people often say, like, why is this functionality missing? And the answer is often that it's, we built the infrastructure and there's a plugin that goes on top that actually does everything really nicely. So in this case, let's restart our node. Stop. CLI stop. Stop. And then maybe restart it. Okay. Flash root plugins. Yeah. Okay. I'm an idiot. Bye. Let's edit that and fix my typo here. Cool. Restart. Cool. Now, L1 CLI help me. Cool. Now it's added bling is complete. So we've kind of got through the whole help me thing. It's kind of walked us through everything. Okay. Help me is still a work in progress. It'd be nice if it diagnosed more things and had more things in it. You can say help me pay and give it an invoice, and it will kind of try to give you some advice on how to play. Thank you, Rob. Yes, I did miss the yes. Okay. There we go. Let's try our other one. Summary just provides a summary. It looks like this. It gives you kind of what network you're on. It warns you in this case you've got no public addresses. It says how much you're worth. Look, I've got. Well, I'm test Bitcoin rich. Here you go. Does a quick conversion for you. You can set. There are parameters to set what currency and things like that. How much available outgoing capacity and how much available incoming capacity you have, and kind of this bar chart of your fees. Now, I will just quickly. This is obviously not an interesting graph because there's only one channel, but I will quickly SSH into builder.onion. If I can reach my test node, unfortunately, I'm at home, not at the office, so I need to tunnel through Tor. If I can reach through, oh, okay, you asked about channel capacity while we're waiting for Tor to kind of finally connect, and I'll show you my other testnet node. So channel capacity is basically, we both put funds in. In fact, in this case, L1 put funds in, L2 didn't have anything. So L2 doesn't have any money in the channel. It can't send any money through the channel because it doesn't have any. Then we paid, so we sent what? About 10,000, okay. Lightning CLI summary. It's a little bit slow over Tor. There you go. So this is a real node with a summary. Well, it's a real testnet node. Here you go. Wow, I am testnet rich. This one's got 2 million test dollars in it. And you can see here's all the nodes and all the channel balances. So if we've got capacity, that means we could send all that stuff. If they've got capacity, it means they could send all that stuff, and things can go back and forth. So in this case, we've got Deutsche Testnet Bank has a huge amount of capacity to me, but I don't have any capacity to them, so I can't actually send anything to them through that channel. And see these O here, the vast majority of these are offline. You'll see this a lot on testnet. People fire up nodes and they just blow them away. So on testnet, usually there's a lot of offline nodes, and I never prune these. So here's a balance channel, odd duck, which is offline, so I can't use it anyway. But if I did, we'd actually both be able to make payments to each other quite easily. Oh, so how do you go about balancing? There is a rebalance plugin that can literally say, hey, rebalance from, this one to that one. And you basically rebalance this channel ID to that channel ID, and here's how much, and you can do it. There's also a few autopilot things. There's an autopilot plugin, which I have not played with because it feels a little bit reckless. My mainnet node is actually running something called CL Boss, C Lightning Boss, written by ZMNSCPXJ. And he actually, CL Boss is like an AI that does everything for your node. And it balances everything and figures out what to do and when to put funds offline and things like that. So that's like the Uber autopilot. I gave him my my node because I trust Zeman and he needed a big node to play with. That's my main node for losing money on Lightning. It's there basically for testing. And so CL Boss actually runs that like a boss. So but yeah, I've used the rebalance plugin manually not on my testnet node because I don't care, but on my mainnet node. So CL Boss is another plugin written in C by Zeman, and it basically takes over your node and balances all the things and does all the things and tries to kind of keep it under control. Basically, it takes a lot of control away from you. You can now pay things, and that's about it. And it manages everything else, including doing on-chain swaps for liquidity. It's pretty. Actually, I'm not quite sure what it's doing to my node, but it's producing a lot of logs. Okay, cool. Okay, so I do want to show you offers. So I will get out of this box, and I will reconnect to my DigitalOcean box. Okay. So Michael asked about running an e-commerce website. So there's also the Prometheus plugin, which will give you a nice graphical view of like what's going on. Running an e-commerce website, so it's actually not that hard because what happens is if you run out of incoming capacity, people start opening channels to you in order to pay you. So to some extent, it's fire and forget that way. Organically, you will get channel growth. If you're trying to do things like optimize the fees that you're collecting for routing other people's payments, then that's where you start to like really care about rebalancing and things like that. But generally these days, unless that's your thing, if you're just trying to receive payments, it's actually pretty straightforward to set up a node. Make sure it has a public channel. And so people can find it on Explorers, and then they can connect to it without having to know exactly where it is. Because the Gossip also says how to connect to your node. So they can say, oh, Gossip, connect to this ID, and go. And they'll get that ID from the invoice. Okay, cool. So I am going to enable offers. I'm going to basically do it by adding the experimental options into the config file for all of them. So for each of the things, I'll add the experimental onion messages and the experimental offers flags, and then restart them. So let me do that. Hope this command works. Okay, so I've shut them all down. I've done that and restarted them. Okay, cool. So now we can do this. An offer is like a meta invoice. Oh, I need to redo. Don't. Oh, okay. I should have, because I logged out and logged back in again. I've kind of screwed this up. Okay. CD lightning / source or contrib. What's it called? Startup reg test. And start ln3 again. And of course, that has overwritten the config, so I need to do that again. Okay. Now, L2 CLI, offer 100 sats. Pay me 100 sats, call it coffee for Rusty. This is a lot like the invoice case, except instead of creating an invoice, we create an offer. An offer looks like this. So this is all experimental. It's still in the draft. It's got to go around a few times in the spec process before we kind of nail it down and it becomes widely used. But it is implemented as an experimental option in the latest one, so we can play with it and get some experience. So L2 has created this offer. L1 can decode it, assuming that it has offers enabled. Oh, offer. No, don't decode that. L1 CLI decode that. Okay. You can see in there it's a Bolt 12 offer. It has an offer ID, what chains it's valid on, which is, in this case, reg test. It has an amount in MSATs, a description, coffee for Rusty. It says what node to pay, and it's signed by the node, so you can tell it's authentic. Okay. Now, the way you pay an offer is first you turn it into an invoice. You do a fetch invoice, which is, I know someone asked before. That's that fetch invoice plugin doing the work. Fetch invoice for the offer. Okay. In this case, we get a real offer. This is a Bolt 12 invoice, sorry, real invoice. This is a Bolt 12 invoice, slightly different from a Bolt 11 invoice, but basically performs the same function. Only it has some extra options. So L1 CLI decode. What did I get? Sorry, not that one. Decode the invoice I received. You can see it's LNI for an invoice. It's a Bolt 12 invoice. You know, it talks about what offer it corresponds to. It's the same description, the same amount, but it also has features, has a payer key. When I fetched when I said, oh, cool, I want to take up this offer, give me an invoice for it, L1 gave L2 a payer key. So this is actually L1's payer key. So L1 can prove later on that L1 was the node that actually requested it. Has some information that it stashes, that L1 stashes. A payment hash, relative expiry, all those things you expect node ID. Okay, so then of course we can pay it. L1 pays it. And there we go. A lot just like paying a normal Bolt 11 invoice. Okay, cool. Well, you know, that's kind of interesting, but let's do something a little bit more. Plugin start. /plugins. Let's install the currency rate plugin. Okay. Oh, that will fail. In fact, it gives an error out here because I did not install the requirements, because it has some weird Python things it needs. So let's do the weird Python things for it. And we'll do that. Okay, now the currency rate plugin worked. So to CLI offer. Now, expensive coffee, but why not? Coffee for Rusty. This is a different offer. And the offer is in US dollars. Okay. Decode. One looks at it. No, decode. And there you go. It is currency USD, amount 500, minor unit 2, which is USD. Obviously, it's in cents. So there's 2 decimal points for the minor unit. It's called coffee for Rusty. Okay, so how does that work? Well, remember, doing an offer is a two-stage thing. First, we get the invoice. So L1 goes to fetch invoice on it. Fetch invoice. And he gets an invoice, but you'll notice here, the fetch invoice command also summarizes the changes that have been made between the offer and things we expected there and what's actually in the invoice. Decode the invoice. And we can see that actually it's an amount of this number of MSATs, right? Oh, sorry, decode. There. So now it's no longer 5 USD. The amount is actually an MSAT, which is something that we can pay. The idea being at this point, that can be presented to the user, go, cool, this is what you're paying. And you can actually pay it. So we could pay that. But that's kind of boring. Let's do another offer. 5 USD, actually. And let's make it weekly. Right. Now, I'm going to use -K here because there's a whole heap of offer options that I don't want to use. So amount equals 5 USD. Description equals that. And recurrence equals 7 days. Okay. Right. Okay. When L1 CLI does a decode on that, Now it sees, yep, 5 USD, et cetera, et cetera. But now it's got this recurrence field. Its time unit is 1, which is in the spec as days, and it's period 7, so every 7 days. Okay. So let's try to fetch invoice it. And now we'll see some interesting things happen. Fetch invoice. This will fail because it needs a recurrence counter. So, oh, this is a recurring one. Which one are you trying to pay? Oh, okay. Well, number 0 is the first one. We'll pay number 0. It'll still get upset because, okay, let's do the offer equals and recurrence counter equals. Okay. It'll still get upset because it goes, oh, no, we need a label, right? In theory, you could have multiple of these recurring things going on at the same time, and it wouldn't be able to distinguish. So you need to label each one. Label equals X, Y, Z, Y, right? Okay, cool. Now, it's fetched us a real invoice. Again, it's done the currency conversion and given us their rate in sats, right? But it's also told us about the next period. The next period counter will be 1. The start time is in seconds, and the end time is, so that is the time that the period applies for. And the pay window. The pay window is when you are allowed to pay that, when paying will be permissible. By default, unless it's otherwise specified in the invoice, the pay window is you can pay for the next period in the current period, like so in the period beforehand, you can pay for it. And during the period itself. So, so there's number 1. Okay, let's try to do, let's try to pay it. L1 CLI pay, and when we pay it, it's just like a normal invoice, so we pay it. Okay, cool. No. Now, because it's a recurring invoice, it still requires that label equals X, Y, Z, Y, because it needs to be able to track, oh yes, you definitely paid that. Oh, sorry. Now, this is unfortunately still called bolt 11 equals, because that's the old parameter name. Okay, so we've paid it, we've got a label. Okay, let's fetch invoice number 1. Let's fetch the next one. Okay, cool. That's for number 1. And now we've got period number 1. Again, it's changed it. This is the invoice to pay the next one. And here's the next one after that. Okay, so, okay. Now, date plus %s. It is right now this number. And you can see that the pay window starts for the next one at that time. So we actually can't fetch the next invoice yet. We couldn't fetch number 2. And there's actually 2 reasons for that. One is if we send to the other end, we go, hold on, it's not time yet. But also, you have to pay them in order. You can't fetch invoice 2 before you've paid invoice 1. It is a series. Okay. So your end will just go, no, I can't even start that until we've gone through the previous one. So I could pay that. If I try to pay the second invoice, which is here, right? Right. Oh, I accidentally deleted the letter. Let's fix that up. Cool. So I can pay that, and then if, as I said, if I try to fetch the invoice number 2, it'll go too early. You can't send it for another, whatever, almost a week, right? Okay. So now, so I released this on my webpage. Cool, here's an offer. And the offers are static, right? I can just paste it anywhere and people can get their own invoices and go as many invoices as they want and pay them. Okay. And that week I have 15 coffees and decide to give up on caffeine. So I go, okay, L2. I go L2 CLI, list offers. List offers. Okay. Now, the good question is, I've got a few here. Which was the one that I was paying? Offer equals QG. It ends in 52. Okay, so that's the one that I'm using. So I delete that offer, right? I'm like, okay, L2 CLI, disable offer. We never truly delete an offer because you may have previous things that refer to it. Okay, and it wants the actual offer ID of that one, which is this number here. Okay, we disable that offer. Great, it's now active false. Well done. But if we do a list invoices, we find that actually someone has already paid it, right? Crap. We really want to give this person a refund. Okay, so in this case, we create what's called an invoice out. An offer out. Offer out. Because instead of offering them, hey, you should request an invoice for me, it's like, you should send me an invoice and I will pay it for you, right? Because that's the refund flow. So amount equals, now we're going to not refund them 5 USD, we're going to refund them the amount that they sent us. So amount equals that, description equals refund too much caffeine, refund for equals this thing. Okay. Right. So that creates another offer looking thing. L1 then takes this, decodes it. And the offer is, okay, here it is, it's refund. It's got the refund for, right? It's saying, here's the thing that you have the refund for. And they would then say, okay, I don't want to pay that. I want to send an invoice for that, right? And we'll call it Rusty refund. Cool. Right. So what happened is it actually sent this invoice to, this is all going through the Lightning Network itself, to L2. And this invoice actually proves that I own the key that originally requested. Remember that payer key that's in every invoice, right? This proves that I am the owner of that payer key. So no one else can claim my refund, right? So it sends that through, and then almost immediately L2 actually made the payment here. Status paid, amount paid, MSATs received, when it was paid, and the description and all that stuff. So that's how we do a refund flow. So Offers enables all this stuff, which is why I'm pretty excited about them. And I apologize that it's still currently all very low level and there's no graphical bling, but I think you can see from this how that would all fit together. Cool. Okay, so I apologize for just running through that so quickly. But Michael asked, what's the best use case for an offer versus just creating an invoice? So when you create an invoice, it really is single use. You should not be publishing invoices on Twitter because the first person to use it gets the payment secret. And then any node that knows that can steal any future payments, right? So invoices were really single use for me to a customer. And that's painful because what I really want to do is have a donation QR code that I can slap on things, I can put statically on my website and stuff like that. And Offers gives you that use. But also, you know, so that's the simple use, like basically a static invoice. And there are other technology we could use to do that. But it wouldn't have given us the ability to do recurring invoices, to do things like payment keys where you can prove that you paid something. So at the moment with Bolt 11 invoices, you can prove that it was paid because you have the image. You can't prove that you were the person who paid it. With the payer key stuff, I can prove that, well, I can prove I was the one who got the invoice, that I asked for this invoice to be created. And here I can prove that I paid that invoice or that invoice has been paid, which is pretty close to the same thing. Cool. So this is, and the refund stuff currently, you will have to get that refund offer to them somehow. We don't currently route that through the network, although that's something I've been thinking about. You have a communication mechanism, an anonymous communication mechanism with them already. You could retry that the same way they originally asked you for the offer, they asked you for the invoice and you sent them the invoice reply. You could try to use the same path, which is anonymous to you, blinded. You could try to use the same path to push them a refund. We don't support that yet, but it would be an interesting thing to do because in some cases, you know, they may not revisit your website for a refund. They may not know. So it'd be kind of polite if you, best effort, you could try to push a refund to them. And their wallet would go, hey, a refund's come up. Do you want to take it? And you're like, yes, of course. And you go for it. Cool. So yeah. Okay, newbie question. Is it possible to set up a Watchtower? I have not done it, to be honest, but yes, there is a plugin for Watchtowers. There is Eye of Satoshi run Watchtowers at the moment. And you can set up a Watchtower. No, I have not wired this up to Lightning Charge. I'm actually hoping to get Shesek to work on doing Spark integration for offers, at least for the payment side, so we can do that. So that, yeah, hopefully that will help. It'll give me, at least it'll give me a graphical demo to show people. I can show people, like, charge happening and stuff like that, rather than just being, hey, here, I can type this thing and these things happen, and use your imagination on how cool this will be. When can offers be used on mainnet? Well, I can use offers on mainnet today because I have enabled the experimental options in my on my mainnet node. But at the moment, the problem with offers is that it's experimental, and so you would have to enable it. So it's only in C Lightning. You have to be running C Lightning. You have to enable the options, and then offers should work today. But they're experimental. Even running on this, I actually managed to trigger a bug. Didn't lose any money, but it did print out a nasty warning for one of the things that I did. It's early days. I would recommend playing with offers at this point and seeing what you can do with them, and whether you like the way that the low-level APIs work, and then work your way up. Certainly, I'm hoping that the way the spec process works is you have to have 2 separate implementations of something before it gets finalized in the spec. So the first step is to write the spec and write an implementation to make sure it's kind of basically sane. And the next step is to get another implementation to also implement offers. And when we have that, and no doubt when that happens, you come up with, oh, maybe we should do it this way, it's easier, and things like that. So there'll be some refinement in the spec. So what we've got experimental offers today may not be what they look like finally. We're quite happy to break things if we have to. Right, do all nodes on the route need to support offers, or just the 2 parties that are connected together? Very good question, Carl. The other experimental option that I enabled was the experimental onion messages. And it's the onion messages support that you need between the 2 nodes so that you can send these messages through. There are hacky ways to send messages across the Lightning Network by doing a fake payment, but they actually consume a lot of resources on the poor nodes in the middle. Whereas if you use onion messages, they're actually very cheap to route. They're kind of fire and forget. So the onion message support is also drafted in the spec. And yes, eventually the whole network will support it. At the moment, you need to actually have a path that supports onion messages, which you can tell there's a path, but our current implementation doesn't even retry. So literally it'll go, I found a path, I tried to send it, I didn't get a response, I give up, which is kind of dumb. So the other thing that it can do is actually just open a connection. Now you lose some anonymity there, because obviously if you just open a connection to them and you send a message, that's kind of implying that you're the person doing the paying, rather than being nicely onion wrapped through the network. But it does allow you to bootstrap. So you can just connect and pay. Oh, new question. What is the pre-image? Okay. So the way Lightning works at the protocol level is that it's a contract. If you give me some sats, I will give you the pre-image that hashes to this thing. So basically the secret. The invoice says, hey, I promise you I will ship you, I will ship you a cup of coffee if you pay, what, 953, or 9.5 million millisats, right? If you pay that, I will ship you a coffee, right? And here is the thing, the payment hash, right? I will give you the secret that resolves this payment hash. And this invoice is actually signed. So that's my promise to you. When I take your money, I have to, by the protocol, the only way I can get your money when you make a payment is to give you this payment pre-image. That is basically the secret that matches this payment hash. And the fact that you've got that allows you to prove, hey, hold on, I can prove that I sent you the money. Where's my damn coffee, right? The problem with the payment pre-image is you've seen that too. So you can go, no, I was the one who paid it, right? Here's the pre-image. It's whatever. It's C2, C6, right? And I go, no, I paid it. No, I paid it, right? All that proves is that someone paid it. So the offers layer puts an extra key on that. So we can also go, hey, hold on. But I can prove that I am the one who actually requested this invoice in the first place, because I can prove that I have that payer key. So it gives an extra, so I can prove that it was paid, but I can also prove that I was the one who got the invoice in the first place. So therefore, assumingly, it was the coffee was for me, obviously. So does that answer your question? Talked about the Sauron plugin earlier. It relies on a full node explorer. Yeah, so Sauron is basically named that because it basically allows the all-seeing eye, right? Instead of asking Bitcoin D, it reaches out to Explorer, blockstream.info, for example, and pulls out the information it needs from there, which is great because you don't have to fire up a Bitcoin D if you're just playing around, but terrible for privacy, and you should never use it for that. But it's great for testnet, and it's great for quickly firing up a node. Of course, you could connect it to your own Espora instance, which would be perfectly fine. So Michael asks, is that only an offers feature? Yeah. So the payment pre-image thing is built into Lightning. That's the fundamental layer. But the payer ID is very much a offers only feature. Now, what plugins would I recommend enabling? I would look at the backup plugin, which is good for basically doing more persistent backups. Once you've got enough money in your node that you care, use the backup plugin. Now, I must admit, I do not run the backup plugin, but it's on my to-do list for my node. Not for my testnet node, but at least I should probably run it for my main node, which has has some money in it. Summary I really like. It's at a glance. It gives you kind of a whole, here's how my node is. Rebalance is pretty cool. For starting up, I like Help Me. It needs some work. It would be nice if it was more helpful and gave you more ideas of things to do and what you could do. But it is pretty cool. Cool. Right. Okay, so I'm going to take the last question because we are already run over time. The Historian plugin. It was originally written for historical archiving by Christian Decker, and you'd have to ask him about more questions. But because that allows it to basically easily do deltas between two different points, we use it to power LN-Sync, which is pretty nice. So LN-Sync is a very fast way to basically go, okay, since this time, what has happened to the network? Give me just this burst of everything. It's only really useful if you're intermittent. If you're well connected on the network, the gossip network works extremely well, and you will find out stuff as pretty much as fast as it happens. But if you're on and off all the time, like a mobile app, it's kind of nice to have LN-Sync there for that. So that's kind of what it's aimed at. Are there any HSMs in the pipeline? Yes. HSMs are cool. We have an HSM daemon, which is not really an HSM. HSM stands for Hardware Security Module, and ours is a Software Security Module, so it's not even a thing. But you can certainly currently put it remotely, which people do, and have an HSM. And there is some work on making HSM more intelligent. Rather than just accepting everything it asks, it would have some kind of permissions level. But that is a fairly big thing. Okay, yes, we will post recordings, I believe. And these webinars are scheduled intermittently. There's different Blockstream ones, but I will try to do one every few months. Okay. Cool. Okay. Thank you, everyone, for attending. I hope it was informative. And you're certainly welcome to ask questions on the mailing list or on IRC, where we tend to hang out, and there's a Telegram channel for C Lightning as well. Cool. Okay. Thank you, everyone.